Hello everybody, this is my second topic, who shut my database down. Did somebody ever had this question when you have a typical setup? So this is quite specific, a DBA topic, by the way, that a database went down and it seemed like somebody brought it down and you want to find out who did it. Is that, I must say for myself, I found myself to not really ask myself this question a lot of the times, but nowadays, probably with cloud, but also with outsourcing and having different teams in different regions, this is, I think, still a very viable thing at one time to ask yourself. Well, this is, now I actually got a slide about myself, but I'm still me as the previous one who did a presentation, so that didn't really change in the meanwhile. This presentation is quite specifically about Oracle version 12.102, and the operating system I did my the screenshots on is Oracle Linux 6.8. So if you are using a later version, things might have changed a little, although I think the general idea behind it is still very much the same. Auditing. In most companies, well, auditing holds together with security, and at least my experience with security is that it's something which is pushed upon you, and in some cases the security regulations which are pushed onto me, what is my experience as a DBA, sometimes simply do not make sense and are there only because of compliancy and not to make anyone's work better or easier to do. And it's the sad reality, I think. And in most companies I encounter, auditing is not really being taken care of. Is there any of you who did very special things or made specific modifications in order for auditing? Or is it all just left? I see 2-3 people raise their hands. Okay, well, let's see. Because then it's implemented as part of very specific security rules, right? There are some rules and you apply, you make changes in order to comply with these rules. In these investigations I do in my presentation, I use the default settings of Linux and the default settings of the database. And some of this information might be helpful for you to do a kind of post-mortem investigation, which means that if something happened, probably what is best is make a copy of the file systems on which Linux resides and on which your database diagdest is, and start looking into it, trying to figure out what kind of things you can find on your operating system which show you something which actually happened. So you can, at the end, and that is what most of the time is required, have a natural person be bound to specific actions this person took, because that's in a lot of cases the idea behind it. Regardless of settings, the database performs what is referred to in the documentation as mandatory auditing, and that is that audit information about stop, start, etc. is written to .aud files in the audit file dest, and by default that's Oracle Home RDBMS admin, and this applies to the ASM instance too. Every now and then I encounter a client which has performance problems, and then it turns out that this performance problem is because the ASM instance has millions of audit files in its audit dest, because they forgot about it, because they focused on the database home and the database diag dest, but didn't focus on the ASM home if you're using ASM. And then there is something which is very logical if you think about how it works, but still is for security not a very good thing, and that is the audit files are owned by the user under which the database is run. And it's very logical because it's the database who writes them. But it's also the same user who's stopping and starting a database, which means that if you want to do harm to the company by bringing the database down, you can go into the Linux system, become the Oracle user if you're not already the Oracle user, stop the database, and then remove the audit files. And if you've done that, then it's untraceable. You can't see who did something. So that means they can be quite easily be tampered with. And these are text files. So they are really easy to find once you know the location, which is in Autodesk. And you can just remove them, and then they're gone forever. But this is the only way, actually, in a default configuration that it is working. And this is how such an audit record looks like. So it's, let's see, yep. It says shut down immediate. The user is Oracle in most cases if you run Oracle under the Oracle user. And actually the only thing that describes something unique about the user in the Oracle audit file is this, is the terminal. If you're using the Oracle user, but in a lot of cases for administration, it's most convenient to have multiple databases running under the same user ID. So the only thing which describes something actually about who did what is the terminal. I was quite surprised, to be honest, when I found how this worked, when I started looking into this. And because the audit records span multiple lines, it's quite challenging to process these files, because normally if you're using logs, you try to grab for log lines, which means that all the information has to be self-contained on the same line. But this isn't the case because it's a record, as you can see, which spans multiple lines. If you have a legal requirement, or if you just want to keep track of what's happening, you can use a log gathering product. And you can use remote syslogging. That's one thing. And the example I use in this presentation is using the Alec Stack. And I've got a blog post about it. And essentially what this means for the Alec Stack is you have on your database server, you have a process running which is called FileBeat. In my case, you can use different product for getting log files off a database machine, off a database server, but I'm using FileBeat. FileBeat keeps track of log files, and as soon as a log file is created or added to, FileBeat puts in this information into something which is called Logstash, and Logstash acts as a collector, as a hub, and I enrichen it. I will show you how I do that. And then Logstash, because it's just a hub for these files, stores the data in Elasticsearch, which is a data store and has full text search capabilities. This is one option of doing it, and I will show some of the tricks I applied in a project in order to get information from that. And this is how FileBeat looks like. And for a normal log file, for example, file log messages, I can just say, here is my file, and the document type is messages. That's an actual type. And it will spool it to Logstash. For the audit files, I need to be it can't be this simple, because I've got multiple lines which create a single record. So I say it's a multi-line addition. And the multi-line addition, I say this is the pattern it looks like. And if you look very closely, you'll see that this is this line. As soon as it recognizes this line, so it's an uppercase or lowercase alphanumeric thing with 3 places, then a space, then the same for 3 places, then a space, then a number, which is 2 places, and which can be 2 places. This is how it looks like. If this line is recognized, it will start, and it started matching after this line, and negate is true, means it will continue on processing everything that follows until it finds another line like this, so until it can negate on the same line. That is what is meant. So this way it can swallow in and make one record of multiple lines in the log file. And then I've got, this looks really awful, but all it does essentially is say, I create something which is called Oracle Audit here, and this is Logstash, and in Logstash you say, okay, if the type is Oracle Audit, this applies. And actually what I do here is, essentially I say, if the methods look like action, then I put in a regex here, so I know it looks like a lot, but it's essentially just a regular expression, and if this regular expression matches, this is a field I dynamically create from the input. So I'm not going through it all because it's a lot of information, and if you are interested in doing it, you just have to test it, and you get these slides, so you can apply this. And essentially I'm just going through the Oracle audit line, and I say, okay, a database user, I apply another regular expression here, and that is what I dynamically call or audit user. I'm doing one additional thing which is quite special, and source is the source file name, because I found out that just having what I found out is there is no process ID in the Oracle audit file. However, the process ID is there, but it's in the file name. And by using this regular expression, which is again a lot of stuff which you just have to, if you're interested in it, have to process for yourself. But this picks out the process ID of the file name, so I have the process ID together with the audit record. And if you then look into Logstash, so again, audit derived PID is from the file name. That is why it's pointing to nowhere, because that's not inside a file, but it's a file name. I have an audit action and an audit term. If I then look into, and this is a picture from Elasticsearch, if I then search in Elasticsearch for the shutdown immediate, I can see it's all the same PTS, so that's the terminal. And I can look at a derived PID, but that's all the same. So if I execute shutdown immediate, this is what Oracle is executing based upon the audit files. This is quite simple. However, what is interesting is if you look at when I search for a startup of a database. If you look for a startup, you'll see that there are the PTS is missing sometimes. And this is quite interesting because one of the most prominent things which is missing is if you search in the audit records for startup, it has a missing PTS. So if you want to know who started up the database, and you're only, if you remember from what I just said, if your only thing pointing to a specific user is PTS, then it's kind of painful that your startup actually has no terminal applied to it. So you can't really, based upon a default config for the database, you can't understand who done it. However, because I derive the process ID from the file name, I can see that this process ID is the same as this process ID, and for whatever reason, reasons unknown to me currently, is here the PTS is there. So based upon gathering this information and get it all aligned, I can understand who actually did which PTS was responsible for doing the startup of the database. Because if you're running production, obviously shutting down a database is an action, but sometimes if you have a database which is supposed to be down, it can be equally destructive if somebody starts up a database on a server which is supposed to be down. If only that it's going to consume resources which then aren't available because it tries to allocate an instance of 10 gigabyte or whatever. So, in order to understand, to manipulate the database, we need to relate the database audit data with the Linux audit data. So to be more concrete, we need to relate the database terminal info with a Linux session. And then, if you made sure, and that is what I see most companies do who have a security policy, if you have to log on with a personalized ID and then can sudo to root, by using the terminal information, I can derive this data. The Linux utilities most of the Linux utilities use syslog to log information, and syslog has a specific what is called facility, which is authpriv, which writes all the information, which means all the information is written to. So FileLog Secure contains all the auditing data for privileges. And if you look in FileLog Secure, you'll see that the SSH daemon is logging into it. If you execute su, it is written into this file, and also sudo is writing in this file. In addition to FileLog Secure, you got last, and the last command lists successful logins, and quite, well, I would be happy to see that. The successful logins for last are there by default. However, if you execute last B, it will say that it can't find FileLog B, TMP, because you first need to touch FileLog B and TMP as root first in order to start logging unsuccessful logins. But it isn't there by default. And the FileLog TMP files are not in a readable format. You need a last utility to output information from it. And this is how this looks like. When sudo is not used, so somebody logs on and then tries to do so, the last utility will provide you the details. So if you look at this audit record of a shutdown, it says Monday, January 30, and then if I say last-t for timestamp, and then 2017-01 for January 30 for January 13. So the recovery, point-in-time recovery file format in essence of Oracle. And then I say I want to see PTS1 because I know it's PTS1, and I want to see the first one I encounter. I get the correct IP address. So at this point in time, the only thing I can tell based upon my last data and the Oracle audit file is that this IP address logged on as the Oracle user on this time who shut down the database. But that's only, you've got only the IP address. If you are using sudo and you're using personalized accounts, and again, this is what I find in most bigger companies, the last utility can also provide information about the logon session because the PTS doesn't change. So I'm saying the same here, last timestamp, and then shutdown. And then it says OPC in this case, so I was using Oracle Public Cloud, actually. That's why I spoofed the IP address, because this is an IP address that doesn't exist, as you've probably seen. So that's good. But then you have to go through FileLog Secure in order to understand how this, if this user truly became Oracle, because as you can see here, it says client user Oracle, and you see OPC here. So you then have to look in FileLog Secure for the invocation of sudo. And then you have to align sudo and the TMP files to see who actually sued the root. Because it could have been that there is some misalignment there. So, okay, problem solved, we're all good. Would this be just a nice short presentation? Well, look at this data. It's got a shutdown immediate, for which we previously saw that there was a PTS, and now it's all empty. What is happening here? Oracle Clusterware. If you are using Oracle Clusterware, and I'm doing a lot of Exadata work, and there you have to use Clusterware, but a lot of people find using ASM convenient, me too, because it gives you the ability to spread out your IOs over your LUNs which are provided to you. Then you probably are using CRS-CTL or SRV-CTL. As a result, your audit data will look like this, because there is no PTS or whatever terminal bound to the session who does the stop and the start for you. And I even gone as far as asking Oracle Clusterware does not provide client session auditing facilities. So my conclusion is, and I put it in capitals in big letters, if you have a default configuration and your company implemented something like personalized logons, there is no way to bind a user session to stopping or starting a database. Of course, you can't derive who's been on the system at the time a certain database, or maybe every database was shut down, but you can't really have a one-on-one relationship to a certain session. That's not something you can do. And my guess is that this is a missing link in a lot of security implementations. You really, on Exadata, can't tell who did this shutdown and startup. Maybe you can look in the bash history file of the Oracle user. But if multiple users are using the same user ID on Linux, they will all have their own version of the shell history file, and the ones who's logging out as last will have its file saved. All the other ones are gone. So, short version of this is you can't rely on the bash history file to give you the idea about who did it. And then still, if you can find it, even if you can find it in the bash history file, you can't tell which personalized session who's sudo to root did it. So this is, I think, a weakness in the implementation of it. You can't tell who did it. Then, after searching for more audit functionality, I found the Linux kernel auditing facilities. And this is something which is really, really unknown. And it's in kernel, it's always on, and it's been there for a long time. So if you're using Red Hat Linux or Oracle Linux, starting from version 4, there is this auditing facility which can do great things. And by default, it lists information about logging on or logging off, that's all. And stuff about cryptology and session accounting. And it's not user-friendly to look at, and it's quite verbose for only these things. So it, by default, doesn't help you for Oracle. So this is how it looks like. If you look in the farlog audit.log file. So, by default, this does not solve our database problem. However, with a simple addition of these two lines, in my case, so saying, okay, for execute of SRVCTL, or this entire path to SRVCTL, I'm going to create an audit record, and the audit record has a key or a CRS to it. And a key is something I can use to search for. And this will provide me the details. And the W means watch, and the -px means execution. And this will make the Linux auditing facilities create records whenever somebody executes SRVCTL, CRSCTL, and it will be non-intrusive. Nobody notices anything. To be honest, I have given it thought what it would mean if I start auditing any execution, and that might be a bit too much, but I haven't gone as far as testing it, so I don't know. Because especially if there are multiple teams working on the same systems, doing the same things, like having your databases outsourced and your company doing level 3 support, so specialized support, and some team somewhere else on the world is doing first line and second line support. Me personally, but I don't think I'm the only one, I would like to know what is happening on these systems and have the ability to look what has happened in the past, especially if I see weird behavior. But it's not something I've tested. And once these rules are set, I can just say audit search -I is human readable, and then for the key or a CRS. And then whenever I executed something, it will say this line, and it will say this line. So this says that, this says that the rule has been added. This is freshly after adding these rules. And This is when somebody actually executes something. And that is, again, a lot of information. Whenever auditing does something, the audit framework, it gives you a lot of information. But the first thing which is interesting to see is that I can see that in the shell, somebody executed srvctl start database -d aobg. Second thing is, if you look at this timestamp, this is one record in total. So these are not distinct records, this is one record in total. It's all the same timestamp. And what is most critical and what is truly a great helper is the session ID. Because what I then can do is say audit search session ID 7164, and I now grab for credit acquired, which means log on, user log out, which means log off, and exec CVE, which means execute an executable. And if I then look into it, this line says that somebody using the user OPC logged on using this IP address. Again, this is a spoofed IP address, obviously, because of the 316. But somebody logged on using this IP address as OPC using SSH. Then the credit acquired is invoking sudo. So this invoked sudo and it became root. And the next thing says, let me see, it logged on to PTS1 as, oh, and sorry, this is how it works. This is where the session OPC logged on. This is the invocation of sudo, and it became the Oracle user root, because sudo executes as root in making you Oracle. That's how it works. So it's a two-step approach. So here the session became Oracle, and this is the actual execution of srvctl start database -d aobg, and this is where it was logged out. So using this auditing framework and by grabbing some of the specifics, because it contains a lot of information about cryptology, etc., I can truly see that somebody is logging on, sudoing to root, and then executing, in this case, the start of a database, and then logging off. And then, if you're an Exadata, and I was quite surprised to find this, if you have Exadatas or administering Exadatas, actually Oracle applied a very big audit rule set for you. And the strange thing is, it's really system focused, and the Exadata system is database focused. It's a database system, and there is nothing database specific that I can see on these things. I've made a description of all the things in this framework. So you can't tell who executed srvctl on an Exadata machine by this rule set, because it doesn't do it, but it gives you a lot of nice tags, and it gives you the ability to tell if somebody changed time. And some of the things which are quite good to see is unauthorized file access, and the one which I will be diving into a bit. Well, shutdown of the entire system has its own key, so that is quite an important one. And any deletions, where is it? Yeah. Any successful or unsuccessful deletion. But so much to my surprise, because I'm not aware that this is documented anywhere, but there is a large auditing framework in Exadata purely based on system access, not on manipulating Oracle. So only the set user ID and set group ID executables are audited, but srvctl and CRSCTL are not set user ID or set group ID executables. So these are not watched. So what I previously showed you how you could monitor them should still be applied in order to obtain that information. So here is an example of the usefulness of the audit rules. I got a case where a server got rebooted. And again, this was a situation where we had an offshore team administering servers, and we were working on it, and suddenly a machine rebooted, and nobody knew why. So, what do? Well, at least for me, the first point to look is the log messages file. And what I mostly do if I'm looking for reboots is first look at what happens after a server is rebooted, and that is searching for proc kmsg started, because that is where the kernel starts. So anything above that is something which had to do about the shutdown of the system. So this is the startup time, and then you go up looking in the log lines. And what I saw, and this was Exadata, I saw RDS bind calls. So RDS, that's InfiniBand. So is this something which has something to do with InfiniBand? And to be honest, this specific client case was not only Exadata but also Exalogic, and there have been several cases where InfiniBand actually caused problems. So maybe it's InfiniBand. It's not something which would be extraordinary. So also, a cluster can happen because of stoneit reasons. And stoneit is, if you have a cluster, then the way a cluster keeps stability is by detecting that one of the nodes is not sane anymore, and the way a cluster, and any cluster for that matter, any stateful cluster I should say for that matter, the way it tries to solve inconsistency issues is by rebooting the node. This is very important and sounds very counterintuitive if you look at an Oracle database. But if something is not functioning properly, the way a cluster tries to solve the cluster state is by rebooting it and hoping that it comes up and is okay again. So what I did is start looking into the alert for a database and start looking in the alert log of a database. And sorry, this is the log of the grid. Sorry. And it actually says that the node is unable to communicate with the other nodes in the cluster and is going down to preserve cluster integrity. So this is Oracle Clusterware speaking now. So, and if the CSS, the Cluster Synchronization Server daemon on Oracle, is terminated, your server will reboot. So the actual cause, upon reading these things, might still be InfiniBand, but the reason that the system rebooted is because CSS found itself to be inconsistent with the rest of the cluster and actually did the rebooting for me. And here you see some additional lines saying reboot advisory, etc. That's typically what you will see. So it might still be InfiniBand, but this is the Cluster Synchronization Server daemon who did it. So issues with the InfiniBand network, and CSS, the Cluster Synchronization Server daemon, rebooted the node in order to try to restore cluster communication. And actually it did after rebooting. So is this a network issue? Why did the network go down? So upon knowing that, I started looking at log messages again, and in log messages I started looking into the messages further up, the RDS issues, and these lines said, and these are in reverse, so it's now the recent one up. I started looking down and I saw bond IB releasing active interface. I thought, oh, wait a minute, but that is the stop-start scripts knowingly releasing interfaces. So this is actually not something which has gone wrong or something which made it wrong on the InfiniBand network itself. This is Linux truly just stopping InfiniBand on my system. There is more happening here. And again, this has nothing to do with auditing. This has to do with interpreting what's in the log files. So Linux released the interfaces itself. So it stopped the network itself. And as a result, the clusterware on that same node said, I can't communicate anymore, so I'm going to reboot. Point is, always not only look at the issues, but also look at things surrounding it, additional messages, because these can give you additional information. And a little further up, and this is probably specific terminology to Exadata, but I found bond ETH0 releasing active interfaces. So it's not only InfiniBand, but it was also my Ethernet interfaces which were brought down by Linux itself. So it looks like my entire networking was stopped instead of me having an InfiniBand issue. So it is even a bigger problem. So is there something we can see using auditing on Exadata? I should add here, because Exadata has the added auditing. Well, on a default Linux system you can't. On Exadata there's the extra audit rules. So I started investigating the audit records and the exact time that I could see that the network interfaces were being released in file log messages. And you can use timestamps, so I can use a specific time. And here I found something relevant. Because of the rule that a deletion is audited, I found that root somewhere did an unlink of, where's the file? Farlog subsys. And farlog subsys is the system 5 stop-start scripts. And if you start something, Linux places a file in farlog subsys network, in this case, so that's the networking script, in order to indicate that it started the service, so it doesn't start the service again because it's already started. And what this audit information essentially says is that the user root deleted farlog subsys, and the only way this can happen is if you stop the networking service. So what this tells me is that somebody executed service network stop in Linux, which made the network stop. So that's interesting. But, so this is all one record, but, and this is the farlog subsys network, so that's the network service, and this is the RM command. So, but what is now, and it was successful, so it just executed it. So, and this is an explanation of that, what I just did. The audit session number was 626, so that's session 626. So now I can follow the audit files again, and using the audit files, I can say that somebody logged on from a server called AMS mon something, and then and I X'd out the account because this is a personalized account which logged on, and then it executed sudo to root to become root, and then it performed the unlink add, which is the removal. So this way I can prove that somebody with, well, currently the username XXXX executed service network stop on this server because of the added audit functionality inside Exadata. And I'm not talking about Exadata. If you know your specific security rules to which you have to apply, you can make use of the audit framework in order to make some rules which will give you an insight in some critical functioning of your system. That's what you can do. So, the big picture. The Oracle database logs into audit files which are owned by the Oracle database owner, so they can be manipulated or removed. If you are serious about them, or your company requires you to be serious about them, you have to at least get them off your system immediately. One of the things you can do is set audit syslog level and have them being logged into file log messages. It's extremely important to create a specific channel for it in rsyslog.conf to have them in their separate file, because otherwise they'll pollute your file log messages file. That's one way of doing it. Or the second way is have a log data shipper and ship it to somewhere else. On the operating system, you essentially have the same issue. Anything which you do when you log on as root is logged to files which are accessible to root. So they have to be shipped somewhere else, or you have to do remote syslogging, which is also shipping them somewhere else. So the Oracle database provides audit records, and these can be manipulated. The Linux provides quite a sophisticated audit framework, which, if you understand what your auditing requirements are, can be quite easily, it's not really hard, changed to contain this information. And that's way harder to manipulate because they are not encoded in plain text. However, you can still, as root, just delete this file. So you still need to get them off the system if you are really serious about this. So an Oracle clusterware usage means that you really can't tell by default who stopped or started the database unless you put an execution watch using the Oracle Audit Framework on CRS-CTL and SRV-CTL. So that's it for me. Okay, thank you.